So are you able to hear me all right? All right. So I didn't know, I mean, right now it's just you and me. Is there anything in particular you wanted to go over this evening? Oh, we got Dylan too. All right. So Dylan, I was just asking if there was anything in particular you wanted to go over tonight. I mean, definitely we can talk about Lab 3 if you want. Okay, well, Lab 3 is definitely, I would say, and it doesn't matter what lab set we do. So I know that quite a few people are not a big fan of the golf lab set, but it doesn't matter which lab set we do. Lab 3 typically requires the largest amount of time, regardless of the lab set. So I would say you're probably going to invest a good 10 hours in Lab 3. And it's not so much that it's hard, it's that we're pulling together a bunch of different concepts in Lab 3. So by the time you get to Lab 4, you're going to be like, oh, yeah, that made perfect sense. I don't know why Lab 3 was so hard, but I think it's because these concepts are new. So just to kind of give you a viewpoint, this is what you're going to see when you pull up Lab 3. So up till now, you've only been seeing like 3 of these things, right? So like a class and a test class and a demo, but we've got a whole bunch going on here. And we've got, you can see like the dependencies. So the course is dependent upon the whole. The scorecard is dependent upon the course. The player is dependent upon the scorecard and the course. So we've got a whole bunch of dependencies that are going on in this particular class as well, which just adds to the level of complexity. All right, so let's go ahead and walk through the scenario and pull out any key points, and then we can kind of jump into Lab 3. All right, so let's see, we're rushing to meet John Golf here. Um, and I am in, yeah, Lab 3. Okay. So you're kind of teaming up, or that's the scenario here, that somebody else is going to be working on half of the prototypes and you're working on the other half of the prototypes. Um, I'm just reading through. Okay. For the prototype, only the first 6 holes are going to be displayed, but I think we're going to work, so that's part of the test cases, is that we only have 6 holes. We need to capture the overall information about the course. So we need some information about the course here, how many holes, par for each hole, the length in yards, and so on. So we're going to have that for the course and for each hole. So we, as you can see here, we have a course class now and we have a hole class. So the course class is going to tell us how many holes we have, and in this case we're going to default to 6, but it's going to be how many holes we have and what are par for all the holes, and then each hole is going to tell us this is, it's 482 yards or 72 yards or whatever, and what the par is for that particular hole. Okay. For each player, they're going to record the score on each hole as well as their versus par, which is kind of what we've had so far. And then there's also going to be spotters that are going to look for the drives, how long they were, where they landed, and so on. 4th class. Where was the 4th class up there? There's got to be the scorecard. Well, the scorecard must pull all this stuff together. Okay, so we've got the class, the course module, and then the whole class. Okay, we've got that stuff going on. Then we've got our player class, and we have a scorecard class. Okay, so we're going to have dependencies here where the course class contains holes, hole objects, and then there's a player class that contains an instance of the scorecard, right? And the scorecard is related to a particular course. So they kind of all tie together. All right, so the whole class. Okay, so there's only two classes that you're going to be developing here. Okay, so your partner is going to be developing the class and the scorecard classes. You're going to work on the player and the whole class. So those are the two we're focusing on here in this particular situation. Okay, so for the whole class, we've got 3 instance variables: par, length of the hole in yards, and then a Boolean value that indicates if it's a full drive yard. Okay. So the length of to determine par, this is what you have. If it's 250 or less yards, it's a par 3, 251 to 470, it's 4, 471 to 690, it's a 5, and anything over 690 is a par 6. The distance of a drive will only be counted as full on anything that's 400 yards or longer. So it has to be a par 4, 5, or 6 in order to be considered a full drive yard, and then it's only a par 4 if it's 400 yards or longer. So that would be a true or false condition based upon how long the hole is. The hole constructor and a set length method use the hole's length to calculate the par for the hole and determine the full drive on the hole to be measured. Okay, there's a getter for the length and the par of the hole, so we have a set and a get method. Is full drive hole method returns either true or false only if the length is 400 yards or greater. Okay, on the player class, name of the player. So here's what we're going to have here: the hole number. We're going to record the score as well. So the whole number, the player's score, the length of the drive, and the location of the drive. Okay, so we've got some locations going on as well. So not only do we know how long the drive was for the player, but did they land on the fairway, the green, or the rough? Okay, and then we're going to have some different computations here. We want to or a drive is only considered on target if they landed in the fairway of the green. It counts as a full drive if the hole was long enough so it has a 400 or greater, and it's on target. So it not only has to have 400 or greater yardage, but it also has to be in the fairway or green to be considered on a full drive hole. And only full drives are considered for the longest drive. So we got a lot of stuff going on. So you can see already why this would be complicated. Okay, the player has one constructor where the player's name is a null reference. You're going to make it unknown and set everything else to zeros. If the player has no full drives, this get longest drive returns 0. If it's compute full average and the player had no full drives, you'll return 0. If they compute accuracy and they had no on target drives, they return 0. Okay, so lots of stuff going on in here. And again, you're starting out. So you are responsible for the player and the hole, right? The scorecard and the course are written by the other person. So the code that's provided in them, you do not need to modify. You'll want to compile those particular items, but you do not need to modify them. But you cannot compile them until you get to the one that's at the very bottom. And so if we follow all of these arrows, we can see the player depends upon the score depends upon the course depends upon the hole. Okay. The player also depends upon the course depends upon the hole. So the hole down here is the bottom of the food chain, right? It's the very bottom thing. It doesn't depend upon anything else. So this is where you got to start. You got to start right here with the whole class. Don't even think about those other classes. Don't even let them enter into your brain. All you want to do is get the whole class and the whole test case working first, compiled, completed. Once it's done, then you can compile the course and you can compile the scorecard because these guys are dependent down here. Then once you've got these guys all working, then now you can come up and look at your player. Okay, so the whole. Let's just focus on the whole class tonight. And if we are able to get to the player, we'll just count it as a bonus. So it would be great too, since, I mean, you do have a little bit longer to work on this lab, but maybe if this weekend you made it your goal to get through the whole class, That would be awesome. Okay, so we have 3 instance variables: par, length in yards, and a Boolean full drive hole, which is a true or false, right? Okay. We have our whole test here. So we're going to test our constructor. And remember, the format for testing a constructor is call the constructor that you're testing, do an assert not null on the object that you've created, and then check your instance variables to make sure they're equal to the values that you're expecting. Okay. On our constructor, which we only have one, the constructor gives us the length in yards. Now this is not complete. Okay, so I see what they're doing here. So this constructor takes in a length, so we don't have an empty or default constructor. We have an explicit constructor, and that's it. And it takes in a length. And immediately the length calls this set length function, which is not written. It's down here. So there's 2 things. So you need to figure out par and whether it's a full drive hole or not based upon the length. And you know how to do that, right? We've got our if then else statements. So, and we also know in here we had that table that tells us if it's no more than 200, so it's 250 yards or less, it's a par 3. So you would put a 3 into par, okay? If it's between 251 and 470, it's a par 4. Between 471 and 690, it's a par 5. Greater than 690, it's a par 6. So it's easy enough to figure out your par. And then if it's a full drive hole, it has to be greater than or equal. It has to be at least 400 yards. So greater than or equal to 400 yards, then it's going to be, you're going to set your Boolean equal to a true value. If it's not greater than or equal to 400 yards, you're going to set this to a false value. So that's what your set length is going to be. Now, one thing that I would caution you to do, so this is just going to contain a whole bunch of if statements in the set length, right? You know what your length is. It's right here in your explicit parameter. So you're going to have a bunch of if statements. So you might have if length is less than 251, then you're going to set your par equal, this dot, whatever it is, par, I don't know what the name of it is, the instance variable, equal to a 3, right? Is it an integer value? Yeah, integer value. Okay. And then you're going to move down to your else, so it's not less than 251. Okay. So you'll do an else, and then you've got that going on down here, and then you'll do your if length. So then we would say it's less than 471, okay? And then you'll set it to your 4 and so on, okay? And then you're going to need your if statements to do it. Now, here's what happens all the time, all the time. Like I would bet 50% of you are going to do this, is you're going to say else if length is greater than 250 and length is less than 471, right? You guys might already be thinking about this, right? And you could have put in here less than or equal to 250. You know what I mean? And so then here you say greater than 251. So what happens when you do this, and then you'll do your opening and closing brackets and set your this dot par equal to 4. Okay. So what happens, what the problem is here, is you can never test this statement right there. You can test this, but you'll never be able to test this half of the if statement, and WebCat will deduct a point and say you haven't tested enough of your code. Now, any guesses why you can never ever test that particular statement? Because it seems like, well, sure I can. I can just give it a number of 275 and it should test that statement. Yeah, it's redundant. So right here, we just checked, is the length less than or equal to 250, right? So the only way this statement executes is if this is true. The length is indeed less than or equal to 250. So if I get to this else, the length is not less than or equal to 250. The length has to be 251 or greater. Okay, so that means that this value will never get tested because we already know it's it's going to be, we can never make this less than 251 because it never, or 250, because it never gets here if it's ever less. It will only get here if it's greater than. So you don't want to include these redundant statements. You just want to go with what you know. You know, I already know it's greater than 250 or I wouldn't be here in the first place. So let's just check the upper end and make sure it's less than 471. Okay, did you catch that, Matthew? All right, and so the same thing happens when you're checking for the range 471 to 690. You already know if it's less than 471, this is going to be true and you're going to execute this statement. So if you get down to the else statement, then it must not be less than 470, you know, 1. So you don't need to check it again. Now, I did this with a nested if. You could, instead of having this nested, you could make them individual if statements, in which case you are going to have to, if you make them completely separate, you will have to say length is greater than 250. Again. So if you're not combining them together, like this is a unique statement, and then this is a unique statement, then because they are not combined together, you do have to check both boundaries of it. It is easier to read this way, for sure. Okay, so you're going to check your lengths for all these pars, and then you need to also check to see is the whole greater than or equal to 400, and that one actually will be an if-else, because if it is greater than or equal to 400, you're going to set that instance value to a value of true, and if it's not, you're going to set it to a value of false. Okay. So as far as test cases go, in your constructor, you're going to call your constructor giving it a length. You're going to do an assert not equals null to check that out. And then you're going to need, based upon whatever length you provide, you're going to need to check the instance variables. Did the length get correctly set? Did the par get correctly set? Did the is full drive get correctly set? Okay. Then on the set length, so that you've got your set and gets, which those, you know, the set is up here already with your logic, but the get will just return. So again, remember, it's create your object, call the method you're testing the set length. So here they set it to 249, and then check and make sure that the par is correctly and that it is a full drive whole. So on the full drive whole, remember, it's going to return either true or false. So you can do an assert false when you're expecting it false. So in this case, 249 is less than 400, so this would not be a full drive whole. So you can do as assert false. And then you're going to need to check for the, you know, so check appropriately. So you're going to need to write your own test cases calling the set length for something that pushes it into par 4, and it will change the par as well as could potentially change your full drive whole. And then likewise for par 5 and par 6. And par 5 and par 6 will definitely have a full drive hole. So for those, because their length is just that. So for those, you would do an assert true is full drive hole, because you would expect for par 5s and par 6s it'll return a true. For par 4, it's going to depend. And so I would encourage you to set your par 4 to be maybe like 375, and then set your par 4 to be a 400, and make sure it changes from not a full drive hole to a full drive hole. Okay, to just make sure that you have appropriate tests on this. Okay, so that is it as far as the whole class goes. So the tricky part when it comes to this whole class is this whole set length. And then really you're just testing the constructor, the set length, and then the get length is a part of it. So that part is not too bad, right? Yes, go ahead. No. A nested if is an if inside of an if. So these are two completely separate and independent if statements. All right. So in this case, this is an if statement up here, and then this is a completely separate if statement. So I could also have an if statement that says if I'm just trying to come up with something that doesn't give away the whole solution. So if par equals 5, you know, I can take one action, else take a completely separate action. So here I could return true, else here I could return false. So this is an if statement here that's independent, but it only takes an action on a true condition. Yeah. Okay, great. Okay. So this is it for the whole class. So really very straightforward, just some if statements in your set length, not a whole bunch going on, but if it's not working, nothing else is going to work. So settle into your whole class, get your constructor going. Well, the constructor is written. The only thing that's not written for you is the set length. So that's the only thing you've got. And then over here, they're only testing the set length, but you might also add in something to test, well, I mean, to get the par, and you're testing all of that as part of this because you're going to call the get length, the get par, and the is full drive hole. So just make sure you've done sufficient test cases for your whole class, and then this will be fine. Once you're done with your whole class, then you can compile and test this. This one is not dependent on the player. The course is only dependent on the whole. So now you can compile and run the test case for the course. You're not having to do anything with it, no coding or anything. And then the scorecard likely is there's only an arrow coming from the score to the course, and likewise from the course to the whole. So you can compile the scorecard as well. So all of these will now, these middle ones will now compile. And then you're ready to jump into this player. And this is the one that you're definitely going to want to break it down and take it in pieces. Okay, so you're going to notice some differences here. We have a name of the player, which is great, but now we have an object, a scorecard object. So this is where the Java docs become critical, and I am talking critical, okay? And then we have 4 integer values: the number of longest drives, the number of full drive yards, the number of full drives, and then drives on target. Okay, so those are all counters that tell us those things. All right. So if I come out here, if I can get there, come on, here we go. Project, oh no, tools, project documentation. Oh, it won't do it because it's not compiled. However, it should be out there. So if we go to the, come on, folder where this stuff is stored, in here is going to be a doc folder, okay? If you double click on this doc, well, shoot, he did not create them. Well, plus lives, no. Yes, if you go into the plus lives folder, so if you're back at the base level folder and you double click on the plus lives folder, and then you click on the doc folder within the plus lives, in here you can see here's the whole Java docs, okay? There is the course Java docs. There is the scorecard Java doc and the player Java doc. So here's all of your Java docs. Now remember, you've written the whole class, so you know that one pretty well, and you can easily refer to it to find out what's available, but you're not writing the course or the scorecard, and then you're writing the player. So it's, rather than flipping in between each one of these, it's kind of nice to be able to go to the Java docs and go, oh look, I've got a constant called num of holes, I've got an add hole, I've got a get hole method. If I go to the scorecard, I'm going to have one of these objects inside of my player, so I need to know what's available to the scorecard, and it's got a method called compute strokes, compute versus par, get holes played, get score on hole, record score, and a toString. So I can tell what things are available in my scorecard class. So this is where you're going to want to keep these Java docs up so that you can see them at all times. All right, let's go back over here. Okay, so instance variables, we've got the scorecard object that now has all of those methods available to it that we just saw. Okay, all right, so player class, we are supposed to initialize all of our instance variables, right? Oh, the other thing is, in your test class, we're now actually taking advantage of the setup and the tear down component that we've never taken before. So in the setup, they are actually adding some holes to the course. So there's a course object, and they're adding holes to this course. So we will have 6 holes on our golf course. Hole 1 looks to be a par 4. We've got a par 5, a par 4, par 3, and I'm not sure what that is, par 4, and then a par 6. Okay, so we've got 6 holes on our golf course. All right, we're going to test our constructor. We're calling our player object, passing it. So our constructor has one explicit parameter, which is the name. So you're going to set your name equal to that. We'll assert not null. And then you need to check each one of them. So each one of these values should be set equal to 0, but you also need to create a scorecard object. Now, it does say a few little notes here. Initialize all the instance variables. Look for and handle a null reference for the player name. If we go back here, it says if the player's name is a null reference, make the name equal to unknown. Now, null is not, so you can't say if player name equals, okay, that's not null, that's an empty string, and that is not the same, all right? So you have to actually say if player name equals null. Null is actually a keyword. That means it doesn't contain a value. Remember how we're kind of doing in the constructor assert not null? Null is actually a keyword that represents the null value. So you need to check to see if the player name is equal to null. If it is equal to null, then you're going to make the player name equal to unknown. And if it's not equal to null, then you're going to set it equal to whatever value comes in. Okay? So you're going to actually want to test for that, because here we're testing to see if it's Nicholas, but you're also going to want to test it to see what happens if you pass in a null value. And you can do that by repeating the same thing here. But instead of passing in Nicholas, you could just pass in null. And then make sure that when you get the name, that it comes back as unknown. Okay, and all the other ones will have a value of 0. You're also going to need to finish the initialization of the scorecard class, which takes us back to our Java docs, the scorecard object. The constructor is just scorecard passing the name of your player. Okay, so it tells us you call scorecard here, public scorecard, giving it a string value, which is your player name. So you're going to need to create a scorecard object. Now again, the key when you're defining instance variables is this dot. So this dot card equals, and then finish your constructor, which is always new, constructor name, and then any parameters inside, right? If you go like this, if you say scorecard card equals new, blah, 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 what you're doing is you're creating a brand new local variable that exists within this constructor that just happens to have the same name as your instance variable. And as soon as this constructor is over, this object, because it's a local variable created inside of your constructor, as soon as your constructor is over, it ceases to exist, and you'll end up getting null pointer exceptions because you think you've defined this one when what you did is you defined a local variable. Okay, so always whenever you're referring to your instance variable, start out with the keyword this dot, and then that way you don't run into the issue of defining a local variable. Okay. Record play. So recording the play, we have the whole, we have the strokes, we have the yards, we have the location. Okay. So when we're recording play, we are going to be updating all those things at the top. Okay, so we know the whole number, and it says we have to make sure the whole number is valid. And so how do we know if the whole number is valid? Well, we need to go to our course, and we need to retrieve the whole. What happens if it doesn't have one? So this returns us a whole object if we call the get whole. So I assume if the whole isn't valid, it's going to return us a null value. We know the number of wholes, so maybe that's where we can go, is the whole number has to be less than or equal to the number of wholes. So it's got to be greater than 0 because you can't have a whole number of 0, right? And it's got to be less than or equal to the number of wholes. Now this is a constant called num of wholes that's in our course class, and it is defined as public, so we have access to that. So in here, looking at the number of wholes, you can say if the whole is greater than 0 and the whole is less than course dot num, whatever it is, num of wholes, then we know it's valid. Okay. You could actually not this whole thing and say, you could flip it the other way and say if whole is less than 1 or the whole is greater than course dot num of wholes, then just return, and that gets you out of that whole if nested if thing. So you could just return at that point. It's not a valid whole. We're not processing it. Move on. Okay. And then you're going to move on. So it is valid at that point in time. And then your job is to record the player's stats for the whole. So you're going to have to do record the scorecard class. See how confusing this is getting already? On the scorecard class, we have a record score. So you're going to call you have your instance variable, and here you got their whole number and your strokes, right? So you're going to need to call this .card.record score. Record score takes in the whole number and the strokes. You know the whole number and the strokes here, so you're going to pass them in your explicit parameters. So that's going to record your score, but then you also need to update your instance variables up at the top. So we know how many yards the drive was on. We know the location. So you need to determine, so you have the strokes, the score on the, where are we at? we need to determine, so only full drive holes are considered, right, for any of these things. Isn't that what the Word document said? A drive is considered on target only if the recorded location is a fairway or a green. A drive counts as a full drive if it had sufficient length and it's on target. Okay? Only full drives are being considered for the longest drive. So your drives, yeah, then let's go back to the whole class. So the first thing we can do is we can determine drives on target. So we can figure that one out. That is easy. Is the location a fairway or the green? If it is, add 1 to our drives on target. Okay, right? We are only adding to our full drives, this full drive 1 and the full drive yards, if it's on, so if it's a fairway or green, so it's on target and it's a full drive hole. So how do we know it's a full drive hole? We can call our hole, so we can get the hole. We know what the hole number is, right? So the course, so we're back to the course, has get hole, which will return to us a hole object. This is wearing me out just talking about this. Okay, so we'll figure out. We're recording the score. So if we get down here, if it's an invalid hole, we're out of here, we're done, right? This is invalid. So if we get down here, life is good. And we know we've got a hole. So the first thing you're going to do, you're recording the score no matter what. That happens every single time, no matter what. Okay? Then you need to find out, are we on target? So you're going to check that location. If your location is on target location, then you're going to add 1 to the on target counter. Okay, your instance variable on target. Now, as long as we're on target, then we get to determine these other things. If it's a full drive, and so on. So it's a full drive if it meets all that other stuff. So we need to get that hole to figure out. Okay, so if it's a full drive, then we're going to do our hole, temp hole or whatever you want to call it, equals course.getHole, passing it our hole number. Okay, so that retrieves our hole object. Okay, now we can find out, is this a full drive hole? So if temp hole dot is full drive hole, or whatever the name of that particular function is, you'll have to go back to the Java docs to find out. Get hole here gives me that information. Then you have to go to your hole class. Am I in the hole class? Oh, they called it is measurable hole, and that's not what it is. It's called, inside of ours, it's called is full drive hole. Okay, so you can call that one. And where am I at? So if it's a full drive hole, now we know we're on target because we just checked that. Then if it's a full drive hole, then we can add 1 to the full drive hole counter, full drives counter. We can add our yards to the full drive yards counter, right? So we're going to add 1 to the full drives counter. We're going to add the yards to the full drive yards counter. And then we need to do one more check, right? We need to say if these yards are greater than the longest yard, then we're going to set our longest yard equal to the new yards that were specified up here, drive yards. Oh my goodness. So did anybody follow that? What do you think? Yeah, I mean, it's kind of messy stuff, but so if you're testing this, you're going to need to test, you're going to need to test something that is like an invalid hole, right? First, to record play, you want to test a hole of like -4 or something that's below 0, make sure nothing happens. You want to test a hole that's greater than the course number of holes, and you can do that by maybe just adding 1 to course.num of holes and make sure nothing happens. So make sure all of your instance variables stay exactly the same. Then you want to record one that's in the fairway and make sure that it bumps up your holes on target by 1, right? And affects the other ones appropriately. So maybe you start out with a par 3 or something, so that it's not going to add to any of the other ones, but it's only going to affect your on target. But you need to give, so the valid entries for that target fairway, green, and rough, or anything else, but you only care about fairway and green, right? An on target hole is a fairway or green. So make sure you give it a rough and make sure nothing happens if it's in the rough, right? You're going to record the score, but you're not going to add to any of your instance variables. So give it a rough, give it a sand trap, give it anything, and make sure that nothing happens, and then give it a fairway, give it the green, make sure in both of those cases it bumps up your target. And then you're going to want to give it different, so here they've gone with all of these different things. So they're giving you a bunch of different situations here. So check your test cases, like what should have happened. Each one of those instance variables will be impacted in some way, so make sure that you test those instance variables, which are the drive holes, longest yard, number of full drive yards. So you want to test those after each situation. Okay, get name, thank goodness. So for me, I would start with the constructor and the set and get name, right? Well, I guess the get name, there is no set and get name. So these longest yards, full drives, okay, average drive. So the full drive average is a little bit trickier, because if you want to get the average, return 0 if no full drive. So the first thing you have to do is check, do I have any full drives? Because if you don't have any full drives, you're going to end up in a divide by 0 error, and you're going to have a runtime error. So first check your full drives. Is it greater than 0? Or is it equal to 0? Then just return 0. If it's not, then you'll just calculate the average, which is your full drive yards divided by the number of full drives, right? Now, how are those both defined? Integers. So you need to take that into consideration, or you're going to end up with your average being truncated. So you want to take into account that would end up being integer to division, and that's not what you want when you're computing an average. Drives on target, compute accuracy, so the percentage of drives on target. So if no holes have been played, you're going to return just 0. So how do we know how many holes have been played? On the scorecard, there is a get holes played, which is going to return to you the number of holes. So you can do a this.card dot get holes played to tell you how many holes have been played. You're going to check that value. Is it equal to 0? If it is, you're just returning 0. If it's not, then you're going to divide your number that were on target by the number that were played to get your accuracy. Clicked on the wrong one. Sorry about that. And then we're done. Oh my goodness. So can you see why I might suggest that a little bit more time is needed for Lab 3 than perhaps you have previously spent? No, they weren't. And you can see this one is starting to actually show you how a program starts getting, you know what I mean? Because we are now integrating 4 different classes and having them all work together. So, up till now we've only been doing one with, kind of minor stuff, and now you're seeing how we can actually build things and work them together and have them all, you know, dependent upon each other and how important it is. We'll cover the terms coupling and cohesion right around week 10 or 11, and you'll see how that all comes to play as well. But yeah, lots of stuff going on in here. So like I said, work on the whole class first and get that working so you can compile the card and the scorecard classes. And then if you get a chance, I would like for the player class, if you can at least get everything so it compiles, which I don't know that these will compile. They won't at this point. Well, because I've typed a bunch of junk in there, so it won't compile. But if you can get them all to compile, then I would go up to tool before you even can get started on the player class. I'd go to tools, project documentation, and then regenerate. This won't regenerate because it doesn't compile here, but as soon as you can get these guys compiled, you can regenerate, and that way you'll have a clean copy. I mean, you can open these guys up and look at them if you want, and you can see what methods and things are in here. But sometimes it's easier to just work off of the Java docs. And what happens is in week 4, we're just going to start giving you executables, so you're not going to have the code to look at. So you really want to get in the habit of using the Java docs whenever you can. Yep, exactly. It'll be a black box for sure. See, you guys picked some stuff up off of last week's session. All right, well, that kind of takes care of Lab 3. Do you guys have any other questions for me? All right, well, we'll just go ahead and call it a night. And, well, let me take a look real quick at the week 7 homework. Because you guys didn't have week 6 homework, I don't believe. No, thank goodness, huh? So this, yeah. So you would be finishing up week 6, but there is no week 6 homework. I wanted to just look at the mini lab for this week. So this will at least be, you have an assignment. And you're going to record a single score, so only one score, so not a ton of scores, just one score, and you're going to be doing these. But you guys have a whole week to worry about this one. So just based upon that one score, you're going to determine maximum, minimum, and all of that stuff. So we must be introducing arrays this week. All right. Well, it records multiple scores, but only one score at a time. So when you call the record score class, it takes one score, but inside of the assignment, it'll store multiple scores, but just one at a time. So, all right, cool. Well, I'm just going to go ahead and call it a night. Definitely, if you run into anything, you can send me an email. If you get a chance to work on Lab 3 this weekend, I would highly recommend at least knocking out that whole class so that you know that component is finished. Definitely take advantage of the Piazza. So we're in week 7 now, halfway through the course. Piazza is the only way to earn any extra credit. So post questions, comments, whatever out to Piazza so that you can earn the maximum. You can earn up to 30 points potential of extra credit. So it's well worth it if you can even just post your thoughts, or even just even if you were to post, hey guys, I just saw a review of Lab 3, better get started now, kind of a thing. Any of those sorts of things count. So, all right, I'm done talking. Have a great weekend, everyone. And, well, I guess I'll see you potentially on Thursday.